Hello, everybody. A warm welcome to you all. I'm being slightly hesitant not to go too quickly because I can see there are still people joining us. So we won't get started just for sort of 30 more seconds perhaps, but welcome to everybody. Oh, wow, it's so wonderful to see all your hello messages in the chat. It really makes us feel like you're there with us this morning. That's the disadvantage of an online webinar, that we can't actually see you. And please don't worry if you cannot see anybody apart from me and my colleagues, because that's intentional. I think we should get going. Welcome to everybody. My name is Liz, and I'm here with my colleagues Charlie and Claire. We'll give you a quick wave. And we all members of the NRICH team, which are based here in the University in Cambridge, a joint project between the faculties of Maths and Education. And we're really excited to be thinking mathematically with you this morning, we hope. The aim of this session is to introduce you to one of our favourite tasks on the NRICH site and to work on it together. During the session, there'll be plenty of opportunities for you to participate using the chat facility, which you've already been using. If at any time you have any concerns and want to contact just the three of us as panelists, then please do email our events email address, which is events@maths.org. And I can see that Claire has already posted that in the chat somewhere. So without further ado, I think we ought to get on and do some maths on this Saturday morning. Charlie, I'm going to hand over to you.
Thank you, Liz, and hello, everybody. I'm hoping you all have paper and pencil handy. If you've got some sort of little bit of scrap paper, you might find it useful to just cut up 5 or 6 squares. I hope you can see me doing this. So we're going to need 5 little squares to start with, and if you can't, it's not a problem. And on them you can write the numbers 1 to 5. So I've already done this in preparation. It seems quite bright here. I'm not sure you could see that. I've got some bigger numbers here. Are these easier to see? Hardly. I've got too much sun coming.
Yeah, it's wonderful. You've got too much sunshine, Charlie, but it doesn't matter. Yeah, that's good. That's good. We can see those. That's brilliant.
So, but if you haven't got scrap paper handy to cut up, don't worry. Okay, but you will need paper and pencil so you can write. I'm going to share my screen so that you can see me scribbling as well. Okay, so Liz, I'm assuming you'll sort of nod every now and again if I just want to check that you can see my screen. Okay, so with these 5 bits of paper with the numbers 1 to 5, what I'd like you to imagine doing is arranging them into a V shape. So what I have in mind is you take your 5 little squares or rectangles and you arrange them into a V shape, and the numbers inside them, you could just put them in any random order you like. So I'm not expecting you to put 1, 2, 3, 4, 5, but you can if you like. But ideally, you just put them in a fairly random way. And And that way we're going to have a variety of combinations. And once you've done that, what I'd like you to do is add the numbers along each arm. So I'm going to ask you to add the numbers on those three positions, or those three cards. Add the numbers in those, along those arms, along that arm. And I'm curious about whether anybody gets the same total along each arm. So if you got the same total along the left-hand arm and the right-hand arm, could you post in the chat the order in which you wrote the numbers? And when you write the order, what I'd like you to do is start with the number you put in the top left, and then work your way down the V, going from left to right. When you get to the bottom of the valley, then work your way up to the top of the right arm. So Liz, would you mind looking at the chart and telling me whether somebody has got 5 numbers that they've arranged in such a way that the left-hand arm adds up to the same as the right-hand arm?
I will indeed, Charlie. Yep, I'm on it now. Oh, it's coming in so quickly, Charlie, that I'm struggling to keep up here.
I just need one.
Yep, I've got one here. So Charlie, from top left, we've got 5, 1, 3, 4, 2.
Okay, so I'm going to just check that this does indeed make what we're going to call a magic V. So it's a magic V if the left-hand arm and the right-hand arm add up to the same total. So 5, 1, and 3 add up to 9, and 3, 4, and 2 add up to 9. Fantastic. That is a magic V. Good. I'm just wondering, are there other magic Vs where the total on the left arm and the total on the right arm also add up to 9? Is this the only way of getting totals of 9? So while everyone thinks about this, and again, you can type, I'm going to copy this onto the next page and try and write this a bit smaller. So Liz, if anybody gives you a V where the left and the right do both add up to 9, can you read them out to me, please?
Of course, yes. So it's quite interesting, Charlie, because I don't think we're in total agreement here. A couple of people have posted that they don't think it is possible.
Okay.
But I've got 5, 1, 3, 2, 4, Charlie. What about that
5,
one?
1, 3, 2, 4. Yes, that works.
Yep. I've also seen one where we've got 4, 2, 3, 1, 5.
That also works. Left arm adds up to 9, and so does the right.
And let me scan through here. Oh, hang on. Yep. One more. I think I've got another one. 2, 4. 3, 1, 5. Oh, 2, 4, 3, 5, 1 as well, Charlie. Oh, 1, 5, 3, 2, 4. Sorry, Charlie. I'm not looking very carefully at what you're writing, and so I'm leaping ahead.
I'm just checking that I haven't.
Oh, now that one's that. That's a repetition. Did I say 2, 4?
No, we haven't had.
No, it's not a repetition. Beg your pardon. Beg your pardon.
We haven't had this before.
Haven't had that one.
I think there should be 8 altogether, Liz. So I think we're just missing 2.
Okay, I wonder if we can figure out what those 2 are.
Yes. Okay, well, tell you what, Liz.
Yeah.
Let's try and help a little bit here. We've got here 2 that started with a 5 and a 1.
Yes.
And it's interesting that opposite, you've either got 4, 2 or 2, 4.
Yes. That is interesting, isn't it? So I don't think there's another way of, if we stick with 5 and 1 in that order, I don't think we can have those 4 and 2 in any other order, can we, Charlie?
And again here, look, you got 2, 4
Yep.
on the left-hand side.
Yep.
And again, 1 and 5 and 5 and 1. But we haven't got alternative pairings here. So I think there may be another version which starts 4, 2. I think there may be another version that starts 1, 5.
I would agree with you, Charlie.
If anybody posts something, can you?
Yeah, 4, 2, 3, 5, 1.
4, 2, 3, 5, 1.
It's brilliant. They're coming in so quickly, Charlie. I just cannot keep up. But I think we've got 1, 5, 3, 4, 2. Yep. Somebody's put 1, 5, 3, 4, 2 question mark. I wonder why the question mark.
Okay, so this is great. So here we have the 4, 2 and the 4, 2.
Yep.
And you can either have a 5 and a 1 or a 1 and a 5. And likewise with 1 and 5 on the left-hand side. Okay, so I think those are the 8. Now, in a way, because all these magic V's have arms that are up to a total of 9. So we have 9 on the left arm and 9 on the right arm. Because when we talk about the arm, we do include the number at the bottom. I know that here I've just been concentrating on the 2 numbers that are opposite each other, but the whole arm adds up to 9. I'm going to just think about all these magic V's that we've just done as being identical. So what I'm really interested in is whether there are any different magic V's that can be made with these 5 numbers. So we started with the numbers 1 to 5. We've got 1 magic V's where the arms add up to 9. Are there any magic V's where the arms do not add up to 9? So I'm interested in magic V's that are different. From now onwards, whenever we're talking, I'm going to just count these as all being identical. I'm not interested in coming up with 8 different combinations. What I think is more interesting is which different magic V's can we make? So my question to everybody is this. Can you play around with your numbers? And if you've got cards, the reason we suggested writing the numbers on bits of paper is that they're much easier to move around and combine. What other combinations can you find? What are the totals?
Charlie, people are coming in thick. There are thick and fast responses to your questions.
Can we give everybody a minute to think about it before we start
do that.
Sharing solutions?
One moment, a minute to think about it, and then let's share some. Great idea, Charlie.
Is that large enough, Liz, for you to see what I've written?
That's perfect, Charlie. Yep, yep.
And it's okay to do it without the borders around the numbers?
Yes, I think it'll be, now we've got the hang of what we're doing, I think that's going to be fine. It's very clear. Yeah. I'm laughing at the speed at which the responses are coming. And I'm also enjoying, Charlie, the fact that we've said that that the magic V's with the total of 9, we're going to count as the same, all the different, even though we know we can rearrange the numbers to still make 9, we're going to count that as one magic V, if you like. I do like the fact that even though we've said that, some people are challenging themselves to find all the options in each case, which is nice.
Okay, so Liz,
okay.
I think we've had a minute. So can you give me some other combinations?
Yes, of course.
Actually, I've just decided I want to do something slightly different here. So I'm going to just rub that out. Okay, fire away.
Okay, so many people have posted that that they think it's possible to have a magic total, if you like, of 10, for example. And so here's an example of a magic V with 10, Charlie. 1, 4, 5. 3, 2.
And that indeed does give you totals of 10. I'm just going to make a note of this. So the 10 there is sort of what each arm adds up to.
Yeah.
And before that, we had magic totals of 9, didn't we?
That's right. That's right. Yeah.
Let me just remind myself. It was 5, 1, 3, 4, 2. I might write that down here to 5, 1, 3.
That's a good idea.
4, 2.
And then we've got, so obviously we know we could write the magic total of 10 in different ways, the different ways of organizing the digits, but there are several ways of doing that. But we've also had many people suggesting that we can find a magic total of 8 as well. For example, somebody has just very recently posted up as a magic total of 8, 5, 2, 1, 3, 4.
And we know that, of course, there are different ways of combining those numbers and still getting a magic total of 8, but we're not going to rehearse all the different ways. But like you said, some people might want to just test themselves and check that they can get the 8 different totals.
That's right. That's right.
So
we've had some really nice observations about these magic V's on the chat as well, Charlie. But I wonder whether you were going to maybe ask a few questions about them.
Yeah, so I'm curious about how do we know that there are no other possibilities? So we've got 3 possibilities here. Are these the only possibilities? If they are, you know, is there something special about them? Is there something that's special about the ones that don't make into magic V's? One of the things mathematicians do is they're very observant. They look for patterns. They notice what similarities. Shall we give everybody a minute to look at the 3 that do the 3 magic V's that we've got that we're sharing, and post what they notice?
Lots of people saying a similar thing, Charlie, just phrasing it in maybe a slightly different way.
Okay, fire away.
So we've got the bottom number is odd. Some people are saying we can't have an even number as the bottom number. We think we can only have the totals 8, 9, and 10. Therefore, what else have we got here? Yeah. So there are some different ways that people have phrased it. And interestingly, a few people are starting to think about why that might be the case as well, Charlie. I've seen a couple of thoughts.
Okay, I'm really interested in that question. How can I convince myself that the bottom can't be even? So have some people already started explaining why the bottom can't be even?
Only a couple. So I think it would be good to have a little bit of time. Why is it that we can't put an even number at the bottom of a V for it to be magic? Why can't we create a magic V?
So I'm leaving you the difficult job, Liz, of
No, it's fine.
reading through comments from 100 odd students and be able to pick out.
And the lovely thing is that, Charlie, everybody is contributing so quickly that I'm not having much chance to read each one. So far, I think I've read a couple of ways of explaining.
Okay.
One is, somebody mentioned that one is about it being an odd total altogether. I wonder if we could unpick that a bit, Charlie.
Okay. So I'm going to rub out the commas that I had here, and instead I'm going to put a plus sign. And when I add the numbers 1 to 5, I get 15. So why is this significant, Liz?
Well, I guess so Charlie, 15 is an odd number. And I've got 2 arms of my V, haven't I? So I'd like, and I want the 2 arms to be the same, the total to be the same. So
shall we try putting an even number at the bottom and see what happens?
Yeah, let's do that. So let's imagine we put 2 at the bottom.
Okay. Let's stick the 2 at the bottom.
So
I've used up the 2 from there.
Yep.
So what have I got left?
So if I've then got 13 left. And if I'm trying to make these 2 pairs of numbers have the same total, I can't do that if I've only got whole numbers to work with.
Okay, so 13 is not an even number, so I can't share it evenly between these 2 arms.
Exactly.
So I could have 2 numbers that are up to 6 here, but then the other 2 arms here would have to add up to 7.
Exactly.
Or, so I could have, for example, a 1 and a 5 here, and then the others would be the 3 and the 4. So exactly. I can't share them out evenly.
I can't share them out evenly. So in order to be able to share them out evenly, conversely, if I put an odd number at the bottom, I'm going to be left with an even total, which I should be able to split with my whole numbers. And that's exactly what we've got in the 3 examples that you've already got at the top of your screen, Charlie.
So let me just check. If I put an odd number at the bottom, let's imagine I put the 5 at the bottom, then what I'm left with will be 10 altogether.
Exactly.
So if I put a 5 at the bottom, I've got 10 left, and I can share 10 evenly between 2. I know I've got to find 2 numbers that are up to 5 on one side and 2 numbers that are up to 1 to 5, and it doesn't matter which order I put them in.
Exactly.
That's
So I think that's a really nice way of explaining why we can't put an odd at the bottom. There have been another way of explaining though, Charlie, as well. Some people have said that well, I know that I've got 2 in the numbers 1, 2, 3, 4, and 5. I've got 2 even numbers and 3 odd numbers. And therefore, it feels right. It just instinctively, it feels right to put an odd number at the bottom. Because we've got 3 on each arm, we want to share out the odd and even numbers. So putting the odd number at the bottom feels like I'm then going to be able to create the 2 matching totals. So some people have explained it like that.
So my 5 numbers, 1, 2, 3, 4, 5, are odd, even, and odd.
Yeah.
And what they're saying is, if I put an odd number at the bottom.
Yep. So that leaves me now with 2 odds and 2 evens.
Yeah, it doesn't matter which odd one, but whatever happens, I'm going to be left with 2 odds and 2 evens.
Yeah.
So I could then have an odd and an even on one side and an odd and even on the other side.
Exactly, exactly.
But if I was to put an even number at the bottom, then I'm going to get into trouble because I've only got 1 even number left.
Yeah.
And the other 3 are all odds.
Exactly.
And so it's going to be impossible to have those arms. That's really nice.
It is
2 really nice explanations.
Absolutely, absolutely. And what I really love about this, Charlie, is that even though we're only using the numbers 1 to 5, and the most we've had to do is do some arithmetic, some subtraction, some addition up to 15. Look at this kind of sophisticated reasoning that we're doing. We are proving why we can't have an odd number at the bottom of an even number at the bottom of our magic V. So I think it's really powerful mathematics that we're doing, even though we're working with very small numbers. What I've noticed on the chat as well, Charlie, is some really lovely questions that some people are putting out there. For example, somebody has said, oh, I wonder if this is something to do with consecutive numbers. Somebody else, interestingly, Charlie, has said, oh, I wonder if you can make magic Vs with different numbers. Do we, not numbers 1, 2, 3, 4, and 5. Charlie, what do you think about that? Shall we?
I think we should think about, carry on to think about consecutive numbers.
Yeah.
Carry on thinking about Vs this size, but I think there's still some more interesting questions to be asked. And I know that you and I have got follow-up questions that everyone might want to work on after this session is over.
Absolutely.
So what I'd really like everyone to think about next, and I'd be quite curious, if we were in a classroom, I'd ask everybody to close their eyes right now. So all of you who are listening might want to close your eyes and just have a think. If you had the numbers 2 to 6. So instead of 1 to 5, you've got the numbers 2, 3, 4, 5, 6. What do you think you're going to have to do to those 5 numbers? How are you going to need to arrange them to get magic Vs? So I want you to do this before you start playing around with the numbers. So what's going to go at the bottom? How many different combinations do you think you're going to be able to achieve? So sort of try and picture it. Just 30 seconds, and then open your eyes, scribble. You're going to need to change your 1 into a 6 so that you've got the right numbers if you're doing bits of paper, and then post in the chat any magic Vs you think you can create with the numbers 2 to 6, or how many you think you can create, or what do you think is special? Can you describe the magic Vs that you can create with the numbers 2 to 6? Are they similar to the ones we created with 1 to 5? What's the same? What's different? Mathematicians often ask that question. What's the same? What's different?
Coming in thick and fast already, Charlie, but we'll give everybody a little bit more time.
Okay, so can you give me some idea what people are posting, Liz?
I can, Charlie. We've got a really nice mixture because people have come at this from different angles. Some people have thought about some different examples, just like we started off doing with the numbers 1, 2, 3, 4, and 5. So, for example, we've got a magic V 6, 2, 4, 5, 3.
6, 2, 4, 5, and 3.
That's right. We've got so another one 4, 3, 6, 2, 5.
4, 3, 6, 2, 5.
And we've got another example 5, 4, 2, 3, 6.
Do you know why I wrote them in this order, Liz?
I think I do, Charlie, and it's made me think I should have been more helpful and given them to you in a different order. But the lovely thing that's coming out, so people are posting individual examples like this. Many people are saying, oh, well, it's got to be an even number at the bottom this time, as these examples show. And then some people are taking the reasoning even further. So we've got some people who've said, well, I know that the numbers 2, 3, 4, 5, 6 add up to 12 this time. Although I'm not sure that's right, is it, Charlie?
Not to 12, because before they added up to 15, and we've got more numbers now.
So that doesn't make sense. I wonder whether I've misinterpreted, without thinking about it, Charlie, I wonder whether I've misinterpreted that, because I think maybe that's a magic total rather than the total of the 5 numbers.
Okay, let's check the magic totals.
Let's check the magic totals.
So
5, 4, 2, that's magic total of 11, isn't it?
Yes.
And then we've got the magic total in the middle there, 6, 2, 8, that's 12. So I reckon I've misinterpreted. Apologies to whoever wrote 12, and I didn't think about it properly. And then we've got 13. So that's nice. People are commenting now on the chat, thinking about the total of the 5 numbers. So here we've got, well, we can quickly write it. We've got 2 pairs, 8. We've got an 8. So 2 8s plus 4. I think that's 20, Charlie, would you say?
Well, I knew that when we had 1 to 5,
yeah,
the numbers added to 15. And this is 1 bigger than 1. This is 1 bigger than 2. This is 1 bigger than 3. That's 1 bigger than the 4. That's bigger. So I think the total has to be 5. We've added 1 to each number.
Brilliant.
Or do you remember that I said we got rid of the 1 and added the 6? So I said, oh, you can make your 1 into 6. All the other numbers are the same.
Yeah.
So in effect, we're adding 5. So I'm being lazy and saving myself the effort of adding 5 numbers.
That's what mathematicians do, though, Charlie, isn't it?
Yeah, we call it efficiency, and I call it laziness.
Yeah. So what is really nice in the chat as well, Charlie, we've had these three magic totals posted, but we've also had some nice explanations using, as you were doing earlier, using E for even and O for odd. So somebody has posted in a V shape. Thank you. Yeah, that's brilliant. So these are now the 5 numbers we have: even, odd, even, odd, even. And somebody has posted that the magic V now can be even, odd, even, odd, even, or it could be even, 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 odd, odd. And both of those arrangements could give us a magic V.
I can see, Liz, why this one here would give you a magic V, because you've got 2 evens and an odd on both arms.
Yeah, that's obvious, isn't it, I guess?
This is less obvious, that 3 evens gives me the same as an even and 2 odds. Can somebody explain why that also works?
Anybody pop an explanation about that?
And just to check, Liz.
Yes.
This is what we have here.
Exactly.
With 2 evens on one side and 2 odds.
Whereas, right, absolutely. So people are saying 2 odds added together make an even. People are creating some nice little equations here. O plus O equals even. And E plus E equals even E. So we know still, even though it's not identical as in the first example, we still know that the sum of each of those arms could be the same, because it's always going to be an even number.
Okay.
Great.
And yes, so, and if we look back, I think at the previous combination we had.
Yeah.
Let me just get rid of this. And I think the same thing happened here.
Yes.
We had odds at the bottom and even and odd, even and odd.
Yeah.
But we also had this one in the middle here, where we had an odd one at the bottom, two odds on the left arm there, and two evens on the right arm there. So that also worked.
Has the two combinations. You're right. Great.
Okay. So
this is interesting, isn't it, Charlie? It's nice just to go back to this slide quickly, because we've got our totals 8, 9, and 10 from this slide, haven't we? The magic totals.
Yes. 8, 9, and 10. And the next one has 11, 12, and 13.
Yeah.
Okay, so let me just write this down. So when we had the numbers 1 to 5,
yeah,
the totals that we managed to get were, this led to these possible totals, 8, 9, and 10.
That's right. That's what we found. Yeah.
And when we had the numbers 2, 3, 4, 5, and 6,
yep,
the possible totals were, did you say 11, 12, and 13?
I did. Yeah, it was 11, 12, and 13. That's interesting.
So as a final challenge, because we're going to have time soon, could we have a magic V, do you think, where the totals for each arm are 100?
Ooh, right. There's a challenge for everybody.
So we've seen,
2 minutes.
Yeah, we've seen magic V's with magic with arms of 8, 9, 10. We've seen arms of 11, 12, 13. Could I have a magic V where the 5 numbers that are being used are all consecutive numbers, and the total for the arms is 100 on each?
So remember, we're saying that the magic total has to be 100. So the total on each arm would be 100. And as we've been saying previously, it would be really helpful if you could post your V in the chat in the order top left to top right. That would be super helpful.
So the order in which I'm drawing them.
Yeah. And remember, we've said consecutive numbers.
Yes, because otherwise it'd be very easy just to choose 5 numbers. Yeah, 3 numbers that are up to 100 and put them in each. I think what's lovely about the magic V's is that they're all consecutive numbers.
That's right.
And if anybody does manage to get a magic V with arms that are up to 100, I'd be really interested in finding out how they managed it. So if anyone in the last few minutes has got time to just share their strategy.
I don't think we've had any solutions yet, Charlie. So
okay.
Yeah, I think it might be one to leave people to think about. Let's see. I think, Charlie, I'm going to be tempted to let people have a little think about this.
Well, we've got quite a few challenges that we've got lined up for people to have a go at. And this seems to be quite a nice example of where noticing patterns. So I'd quite like to share what I notice about what's on the screen at present.
Okay.
Just because what we have in mind for everybody to do as a follow-up is even harder. And so getting used to looking at the simpler examples before moving on could be quite useful. So one of the things that I noticed, Liz,
yes,
is that when I want my magic V to have a total arms of 9, I use the numbers 1, 2, 3, 4, 5.
Yep.
And the number in the middle of this is a third of 9. And the same thing happens down here, where 3 times 4 gives me 12. So it looks like if I put this middle number at the bottom, and then I share the biggest and the smallest number together on one side, and the two sort of numbers that are closest to the center then I get a magic V of 12.
Yes.
Now, we've asked for a magic V of 100.
100, yeah.
Which is not a multiple of 3, but I know that 99 is. So I think the numbers to be used for 99 are going to have to be, I think the middle number is going to be 33.
I agree. And I think we've got some people posting who agree as well, Charlie.
Okay. The other numbers are going to have to be 31, 32, 34, 35.
Right. So then it's a question of thinking about how we arrange them.
Yes. So if I think if I put the 33 at the bottom, I'm going to be able to make a total of 99. So I'll leave people to finish that off because we want a total of 100 rather than 99. And I think with these 5 numbers, I can also make a total of 98. And so I think looking back at what we've done, we got totals of 8, 9, and 10, depending on which, and we got totals of 11, 12, and 13, depending on what numbers went at the bottom. I think some of that could be used to help figure out how to arrange the numbers to get a total of 100. Okay, I'm going to stop there because we're running out of time and we want to show everybody where to find the problem on the NRICH website. And I think you're going to do that. Is that right?
I can do that. That's absolutely fine, Charlie.
Thank sharing you. My screen.
Brilliant. Yep. If I share my screen now, there we go. Are you able to see the screen, Charlie?
Yes.
The website, brilliant. So here we have, if you go to the NRICH website, so you can see the address bar at the top here, nrich.maths.org/6274. You'll see the task that we've been having a go at here. It's called Magic V's, as you might expect. We've had a good go at the first part of the task. We've looked at the different solutions for numbers 1 to 5. We've investigated 2 to 6, and Charlie and I have been posing you a question so that you can get a magic total of 100. Once you've had a little go at that and finished off that last part, what you might like to do as well is have a think about some of the other questions on this page. But particularly, we suggest that you have a little go at another follow-up problem. So right at the bottom of this page, you'll see a link to another task, which is called Magic Letters. So if I click there, you'll see Magic Letters. Now, the first part of Magic Letters is a recap of Magic V's. So you won't need to worry about that at all. But the newer bits for you to investigate further come down here. Why not have a go at a magic L, for example? That looks interesting because that's not symmetrical now. We've got 4 numbers and 3 numbers, a magic N, a magic W. These all have really exciting things for you to explore. And now that you've got to grips with Magic V's, we feel confident that you'd be able to have a really good go at those. We really hope you've enjoyed thinking mathematically with us this morning. Thank you very much for posting so prolifically on the chat. It's been great to know you're working alongside us. When we finish this event very shortly, you'll find that you'll get linked to a very brief feedback survey. We'd love to know what you thought of this morning and what we might do better next time. Thank you very much, all of you, and we hope you enjoy the rest of the festival events that you're attending. Thank you. Bye.
Bye-bye.